So NTT America has been doing IPv6 for a long time. We have a little brief history thing. We've been working on doing this with NTT Labs and whatnot since the early 6-bone days. I personally came out of CICnet, where we ran IPv6 quite a long time ago. And we've been doing this for a long time. We went dual stack native back in 2003 for engineering, and have been continuing to operate it in that case. So the data I'm about to present here is sort of before, after, and during IPv6 day. Here's the technical caveats for everyone who cares. Not all of our network is exporting this data that we're able to see. We're doing NetFlow v9 sampling, blah, 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 and we're mostly looking at customer and peering interfaces. So here's the data. So prior to IPv6 day, we basically, this is the 7 days preceding here. This shows the traffic levels of what we see. We've got about 124 megs of total IPv6 traffic that's viewable on our network. About 60 megs of that's TCP, UDP is about 31 megs, and then there's the wonderful amount of ICMP, which everyone seems to think that IPv6 is full of. We've got the number of flows per second that go and hit our collector. Obviously, that's not a lot. The PPS graph looks pretty much identical to that. There's a few little differences, but that's about it. And then, everyone says, oh, IPv6, it's all just ping. And pretty much throughout the time, there's this standard background radiation of ICMP ping v6 activity that's going on. So for IPv6 day, we did a lot of things. We went around, we dual stacked customer and peer interfaces. We went and did some audits of the routing table, tried to get customers and peers to turn up v6 if they weren't doing it directly with us. And we noticed a considerable amount of growth leading up into IPv6 day in the routing table. You look at this and you say, when else have you seen over the course of a month of time about 370 unique networks, autonomous systems actually add routes into the routing table? There's really a significant amount of growth in the v6 table as a result, and it's actually continued on from that as well. Dave?
Are they non-overlapping prefixes, or?
This is unique ASNs visible. And so this, I'm processing the AS paths,
okay,
and just looking for unique ASNs that show up. So this is just basically a WC minus L of the file that outputs, a prefix and, one of the sample prefixes and who originated it, or if it showed up anywhere in the AS path. But you're talking about a whole bunch of people who added IPv6 into their networks over the past month.
Yeah, I was just kind of curious if we're able to, I know it's really early and everything, but we're trying to analyze this data, and so I was just kind of curious to see if people were announcing more specifics in any way.
Yeah, you see some more specifics in the table, but I really didn't focus my efforts on that. I really focused my efforts on making sure our customers who did v4 with us would do v6 with us as well on those interfaces, because we've been able to do that for many, many years, and just making sure they had that turned up. So here's the big slide, the IPv6 day traffic levels. We saw traffic about double in the network for the IPv6 traffic. As you see, it went up here. We had a couple peaks up in the 200, 250 megs frame. But when you start thinking about that, that's 250 megs globally across the entire network where we have this IPv6 NetFlow data. Of course, it's an imperfect view, but that's not a big jump in traffic overall when you consider how many gigs or terabytes or whatnot, or terabits per second of traffic a pretty major carrier carries. The breakdown of that, we pretty much saw all that spike was www traffic. You've got 64% of it was that. 21% was basically torrenting and stuff. Once you add in the rsync and SSH activity that happens as well, you're up in the 90-something% range. And what's really interesting to me personally is you look at the IPv6 UDP traffic statistics, and that is all DNS queries. It's pretty much nothing else. After that, the ports drop out into some insignificant numbers. So IPv6 is used at least for DNS a lot. So I don't know if anyone noticed on the other traffic slide, since IPv6 day, you can see sort of this tapering off here. There have been some ongoing traffic spikes that we see where we actually are peaking above the IPv6 day traffic levels. That's not necessarily surprising because if you have 2 gig connected hosts on my network, you could go and create something that would show up on this graph if you are doing IPv6 between them. But it's really interesting to continue to see these spikes. And this big spike here we saw there on the 9th was actually in Amsterdam, where we were doing about 300 megs of traffic. So then, since IPv6 day, this shows IPv6 day roughly here in the middle of the graphic. We didn't see any change in the amount of ICMP traffic, which means everyone who was monitoring what was going on beforehand, nobody changed the monitoring they were going for IPv6 day. The background radiation stayed the same, roughly. And we've seen maybe a little bit of an uptick since then, but that's about it. Yeah.
Anything else. I think you might find, if you look really hard at this, these are all the BitTorrent zombies who have gone to Teredo and are failing the rendezvous.
That's entirely possible, but I didn't look inside my customers' packets to.
Well, you don't need to. It is only ICMP. There's no payload, and the fact that it's dark means that you're seeing the standard behaviour of wacko Teredo in some instances. But I think what you will find is what the same as I'm seeing, that all of that ICMP ping are not people pinging. It's actually an application that finds a Teredo interface down there in the stack and decides to use it.
Yeah, that could definitely be the case. So we didn't do a lot of in-depth research on this. We basically were just looking at the traffic levels of what we saw. And then here I've got a last-minute addition. On Saturday and Sunday, I added this in last night. We continue to see pretty big traffic spikes on the graphs, and it does look like we're continuing to see an upward trend of traffic with IPv6. And considering how many networks turned it on in the past month, and I'm guessing a lot of you here are going to go back and do that as well, who haven't already done it. I think we're going to see the ongoing traffic increase ramp up pretty quickly here. So I'm pretty excited about the future of IPv6, and I'm personally hoping for a repeat of the World v6 day and seeing a lot of people turn it on and leave it on for good. So thank you. Oh yeah, and so thank you to ISOC, Yahoo, and everyone who put on World IPv6 Day. It was really awesome to be able to look at it, and it was most anticlimactic, war room type day ever in my experience, but it was good overall. So thank you.
And thank you, Jared. And moving on now, we're going to hear from Barry Green from ISC, who's going to be talking to us about passive DNS.
Okay, this is a quick one on an appeal for all of you who are operators who have some sort of DNS infrastructure, especially resolver infrastructure on passive DNS. The reason why we're bringing this appeal out to get more participants in this program and submitting data into it is this has become a very, very useful tool for anybody who's doing investigative work on what's going on with the badness out on the net. It's becoming a big shortcut. And one case, there was one individual who works at one of the big operators, and he thought he had a pretty good infrastructure in his operations, and then we get him access to the user interface, and he said in one night he got 3 months of work done in investigating some of the badness on his own network. So we're putting this appeal out with it. Some of the stuff, and I'll show this in the demo with it, is all this stuff where the bad guys have been hiding behind DNS and protecting the zone files, and we can't figure out what they're doing. But passive DNS is a tool where we can get behind what they're doing. We can see the badness. In the case with Paul Vixie would say, taking DNS back from the bad guys. This is one of the tools that we're using to do that with. This is an idea that started in 2004. Florian Weimar kind of created the idea, and then people have been involving with it. ISC has been one of the organizations evolving the idea with it. Essentially what you're doing is you're putting a sensor in your resolver network And we only care about that traffic going from your resolver out to the rest of the world. We don't care about any information coming from your clients. So in one case, we're protecting PI information. You don't have to worry about PI information. It's not leaving your network. And then if you're worried about people tracing back that you're a source of some of this stuff, in the actual sensor, you can configure it where the actual ID of the sensor gets turned off. So when it comes into the aggregate, nobody can trace it back that provider X provided this data set, because what we're really looking for is the aggregate all together, so we can get a visibility of what's going on with it. So what I'm going to do right now is jump out and kind of give you a quick demo to give you an idea of this stuff. This is the user interface that you get of one of the tools. This is the DNSDB tool that Robert Evans created over at ISC that aggregates it together. And this is a particular subnet, right? So we can search on whole subnets, and on this, a bunch of people have noticed there's a bunch of PHP Metasploit servers out there, and so you go, okay, what else is on that subnet? Because I only spotted one, and you push it out there, and you know, you start seeing. I mean, already, you know, when we put this in there, you can see this subnet is just polluted all over the freaking place with a whole bunch of malware, criminal sort of activities with it. With the tools that we had before of DNS, we wouldn't be able to see this. Now with this tool, we're able to see it. Where your contribution comes in there is the more submissions, the better, because how this works is based off the demand. You know, some client somewhere does a query into the system, it's collected by passive DNS, it goes into the big database. I'll give you another example. This is a domain name on here that we pulled off with the Zeus tracker. So I go to the Zeus tracker site, this came up as a Zeus command and control center location. So I get the records of it, can see what's going on with that, but then I say, okay, let's start tracking and find out what's on that particular A record, what else is on that server. And it's interesting. This morning when I was setting up this demo, there was four servers on there. Now there's even more, right? So the bad guys in there putting more and more stuff from this particular Zeus tracker. But what's interesting is when I went on this one, and this is one after I get through this demo, I got to go talk to people about it. When I pop up this other IP address, this is popping up some really weird stuff where you got these domain names over here that several of us haven't seen. I pinged some people and says, well, we haven't seen that before. What are they doing with these domain names? And those are domain names people created up there. Some of them are actually targeting eBay. Some of them targeting like the secure login for the Social Security Administration, right? We wouldn't be able to see this if we didn't have this tool set out there. So, right, so this is an example of how this, you know, the passive DNS stuff works. And why we're so excited about it and getting more information out there. Who gets access to this information? If you're connected to any of the SIE nodes, you know, it's a peering thing. You can get access to all channels, and you can build your own passive DNS infrastructure if you want. Or you can get access to API, or you can get access to the user interface that I just demonstrated. The user interface isn't open to the public. This is actually, we actually go through, you have to qualify. If you submit data, you get access. So one of the benefits you get submitting data is you get access to all this. It's a barter sort of thing. You get the data in, you get access out, right? That sort of stuff. And then we make sure that you're, you know, a vetted property. So even the submission of data, we got to check you out. Because it's funny, about 6 months ago, we got this, auto dealership in the middle of Ukraine wanting to submit passive DNS data into us. And we're going like, okay, what's going on with this? And we traced it back, and it was actually one of these auto fraud dealership sort of things going on in Europe. And they're trying to get access to the data. So we're pretty cognizant of the value of this data set, even to the bad guys out there. And applying to get in there, you can go to the sie.isc.org, and there's a step-by-step on here of, you know, first you say, hey, I'm interested in getting in there. We make sure you are a valid individual. Most of the people here in NANOG, we view you all as valid sort of people, and we'll work with you to get you in there. And then it all rolls down to, you know, sending the email message off to dnsdb@isc.org. So again, if you were interested in contributing to the cause, we'd love to have your data come in. And then I think anybody here who's really interested in trying this out, just contact us also if you just want to check out the user interface and see if it's valuable for yourself. Most of the operations and operators out there, NOCs and investigative teams, are authorized to get access to this. It doesn't cost anything for it. Thank you.
Thanks very much, Barry. Let's see here. Working with a monitor that's not on the computer is going to be interesting. And next up, Andy Newton from Aaron is going to talk to you about system changes at Aaron.
Thank you. Oops. I got everyone's attention, right? That's good, because this presentation doesn't lend itself well to pretty graphs and drawings. So anyway, my name is Andy Newton. I'm the chief engineer at Aaron, and what I'm here to talk to you today about is really an update on the things that have been going on in our back-end systems and the changes to our public-facing service interfaces. We've been spending a lot of time modernizing Aaron over the last couple of years, and so that's what we want to. Back in 2008, we updated the web portal, or we launched our web portal, and we continue to enhance that. And then this year, or sorry, last year, we revamped our WHOIS infrastructure, came up with a RESTful interface for that. This year, we had our biggest release ever, biggest software release ever in the history of Aaron, where we put in a RESTful web interface for the registration system, and even more importantly, we revamped the way we model reverse DNS in our database. And we also do, and part of that, the remodeling of the delegations in the database was so that we could do full-on DNSSEC support in the reverse. And of course, we're doing other things. We're looking at our IRR still, and we have RPKI services coming out soon. Aaron Online, our web portal, we launched that in 2008. Last I checked, we had 38,000 users who are signed on when we launched the system. Back in 2008, the only thing you could really do was modify or create a point of contact. Today, you can manage everything that you do with Aaron via the portal system. You can modify POCs and orgs, but you can also change your nets and your ASNs and request services. And of course, with the change to the delegation system, you can also manage your reverse DNS. We still have people working on things back at the office, and so what you're going to see coming up this year is your billing information. That's one of the things that's been requested a lot. There have been a lot of changes we had to do to the billing system in the back end to get it to be unified with our web portal. But in the future, you'll be able to see your invoices and change your billing and invoicing information and see payment information. So we're working on that. With the WHOIS infrastructure, last year in July, we completely revamped the WHOIS infrastructure, put out all new services, all new software, so all new servers and all new software. And one of the things we did was, besides revamping the port 43 service, is we have the RESTful web service on top of that. Today, that accounts for 40% of our WHOIS traffic. On top of that, we added CIDR support. So back in July of last year, we put some initial CIDR support in there, and then in March, when we did our big release, we added some. Basically made it better. So both over port 43 and the RESTful web service, you can now do CIDR queries. And of course, with the changing of the delegation model and how we model DNS information, you can also query for reverse zone information out of DNS as well, out of WHOIS as well. There are other people who are doing RESTful web services for WHOIS data. ICANN has 2 prototypes that I know of, and the RIPE NCC has a system in place as well, which is now in production. And people are talking about trying to come up with a unified standard as opposed to all of us doing it our own way. So there is actually an effort to create an IETF standard. It just started. The mailing list is called WEIRDS, and it's weirds@ietf.org. If you're interested in developing a standard for this, you can participate in that mailing list. And there's likely to be a BOF at the upcoming IETF. The other side of getting information out of our systems is to put information into our systems, and that's the registration side. As of the March release, we now have a RESTful web interface for our registration services. On top of that, we know that people who are writing programmatic interfaces into our systems sometimes don't want to just deploy them and see what happens. So there's an operational test and evaluation environment which you can sign up for. So if you're writing a program to register information into our systems, if you want to test that out without playing with live data, you can sign up for OT&E and test your systems out. We still support templates. The templates have not gone away. Version 3 templates have been deprecated for a couple of years, and so those are no longer supported at all. But version 4 and version 5 templates still exist today, and they're not going anywhere. Version 5 templates, the only real difference between a version 4 and a version 5 is a version 5 template is a lot more explicit about the information needed or the information that's not needed. And of course, everything requires an API key. An API key is kind of the mechanism we use for the registration web service, so we know who's talking to us and we can tie it back into the information in the web portal. The templates also require this now, so you can actually, if you submit a template that requires a ticketed action, you can actually sign on to the web portal and see the ticket there. And that's what the API key does. It also makes the templates slightly more secure. For the reverse DNS, we have full DNSSEC support now, thanks to our new delegation model. Currently, the only way to manage that is through the Aaron Online web portal, but we are adding management services to the registration RESTful web service. And of course, there's routing. We still do routing. We're looking at changes to our IRR systems, and we have been working on and will be releasing as soon as we can our PKI system. So, any questions? If you get back to the office and you start playing with this stuff and you have questions, we have online resources where you can go look up information on our APIs and so forth. We also have the Aaron Tech Discuss mailing list. It's a low-volume mailing list, but that's a place for people to go and ask technical questions about how to interface with our systems. That's it.